Right. So this is episode 20, I think. Okay. Yes, it is. Well, welcome. I really remember this question. I think back in this is the last questions of that exam, and that was back in 2019. So I think that was my first time teaching this BTEC, and I got caught out because I teach my students regarding magnetic flux density and etc. But this time they give you a graph, and the graph hides that informations, and lots of students got sort of thrown through by this type of question. So let's have a look at this, and it's the last question is worth 8 marks. Okay, and that's the only space they give you to work out the answer of the current that required to create a magnetic flux of zero point 0.1 milliweber in the core. Okay, so let's get our formula sheets ready first. Let's do that. And so this is to do with magnetism. And so we're using equations from here, right? So let's assume I haven't revised. So how am I go about to doing this? So if I look here, flux density, well, guess what? They've given you the letter B so that you know what flux density is. And then they give you a magnetic field strength H. So we're going to look for, in this BH curve, um, something to do with B and H formula. So we're going to look here and find something to do with B. So there is a chance that we will need this. There's a chance that we will need this. Uh, B and H, we can work out uh, this because we always know what mu naught, the permeability of free space is. So we can find this out. Um, I think that's possibly, if we know phi, we can find inductance. Now, I don't know if we do we need inductance at all. So definitely those three. Okay. So uh, let's now read the question. So we know 300 turns. So 300 turns is always number capital N. So N is 300. Uh, we need the coil has a length of 0.9 meters. So we know the L. And then we have a cross sectional area. Okay. Uh, so let's see what we need then. Okay, so it will be really good that we can find out what H is, so then we can work out what the magnetic flux is going to be. um, so so let's see if NLA and phi uh, we can use which formula. uh, NLA and L H. So let's put H equal to Ni times L. So we can go here. Um, H is equal to Ni times L. Okay, so we know N, we know L, but we are asked to find current, but we don't know what H is. So we can't solve I. So the question is there a way I can find H? So I'm going to look here. Oh, look at that. H is equal to uh, ah, B is equal to phi divided by A. So phi, we know phi already, and we know A already. We can find B. Yeah. And then once we know B, we can use this equation to find H. and then we solved it. Yeah. So let's write this down. So for some of you, this might have been just gone too much. So because we know phi, okay, so b is equal to phi over a. So b is equal to phi over a. And because it's 0.1 milli, so remember, use SI unit, so it's just Weber, so not milliweber, okay? So you now need to write times 10 to the power minus 3, and then divide by A. Is it in SI unit already? Oh, lucky. So we don't have to convert meter square into, or millimeter square into meter square, so it's already in meter square. So it's just that, all right? So lots of people done that part, but they don't know what to do with the next bit. Um, so once you find out what B is, you can then use the graph to find out what H is, because you want to use the experimental data. So don't worry about um, using the H formula. Use this graph instead, okay? Because that is the characteristics of the core, or of the core in this case. Okay, so it's not, maybe it's not perfect core, is man-made. So use these characteristics. Okay, so we put that in the calculator. So I want, yeah, let's just do it this way then. So 0.1 times 10 to the power of 3 minus is equal to, oh no, don't know how I would be able to write. So 0.1 times 10 to the power of, okay, I see what it's doing. So I need to do 10 to the negative 3 to the power of 10 multiplied by 0.1. So that will give me 0. I mean, I know that, but I just want to demonstrate this on a calculator for you, in case some of you just simply use a calculator in the exam. It's a bit too late now. All you have to do is move decimal point, well, move the place value 3 times to the right, so you can, or some of you will be using the less more incorrectly taught proper method, which is you move the dot, the decimal point, so which is not a very good way to teach students that method. Okay, so, and that divide by bracket 6 minus to the 10 multiplied by 250 close bracket equal, so whatever that is, so it's 0 point, so 1 2 3 4 5 6, so 3 4 5 6, that way it makes it easier to do. So 0.00025, and that gives me the answer 0.4, which I remember that in the exam, and it's Tesla. Okay, remember B for Tesla. Okay, so look at this. It gives you a nice number, so you can just draw a graph that will be worth 1 mark on the graph. Mark your 0.4 where it merged with the graph, go down, right, bang on in the middle, I would say. So let's just say H is 1,500 Henry, and that's what you put in here. So 1,500, so shall we rearrange first, shall we? So to find I is therefore equal to, so you got to times L both sides, so it's HL, and then you have to divide by N to make I the subject of the formula. Do you want me to explain this again. So let's try again. Okay, some of you may be a little bit rusty. So I times L this side, I times L this side, L and L cancel out, yeah? So I got HL equal to NI. Then I divide by N, I must divide by N, so N cancel out, so I is equal to HL over N. And H is 1,500 times by L, which is 0.9 meters, or in SI units, and then divide by number of turns, which is 300. And the answer will be in amps, and that is your answer for this question. So 1,500 multiplied by 0.9 divided by 300, and that is 4.5. Okay, so it's been a while. I think I haven't seen this exam question with a graph come up again. So now we're 2026. You never know. So this might come up. Okay, and yeah, be ready for this. So I hope you enjoyed this video, and it wasn't too difficult now that I've explained. Okay, so good luck.